So to graph an exponential function, our function is f of x equals 3 to the x. You're going to create a table of x values and y values because you need to first graph 5 points. So I recommend always set your x values to -2, -1, 0, 1, and 2. And then y is 3 raised to the x. So I have for -2, 3 to the -2 is 1/9. When x is -1, y is 1/3. When x is 0, y is 1. When x is 1, y is 3. And when x is 2, y is 9. And then these are the points you're going to graph. -2, 1/9, -1, 1/3, 0, 1, 1, 3, 2, 9. Any questions about that part? So now to graph these, instead of just putting your point, because we can graph this one, like we can take our pencil and we can graph 1, 3, and we can graph 2, 9, but we can't graph, and we can even graph 0, 1. And by the way, 0, 1 will appear on every single exponential graph because you'll always get something raised to the 0, and anything to the 0 is always 1. But to graph these other points, these first two, because they have fractions, we have to use this plot a point feature. And then we're going to put in -2 and 1/9. And then if you don't click, it shows it on the graph, but if you don't click plot point, it won't put it there. So be sure you click plot point, and then otherwise it'll just disappear when you do the next one. And then -1 and 1/3, and plot that point. And now we have our 5 points on the graph. And then it won't let us plot until we, and it says do not approximate, okay? And then it won't let us finish, and let me close this, until we add the asymptote. And exponential functions can never have a value of 0. It is impossible to raise something to the xth power and end up with 0. So there's going to be a horizontal asymptote always right on the x-axis. So again, the way you add that, let me just undo it. The way you add that is this adds a vertical asymptote, this adds a horizontal asymptote. So you just click this and then move it to the x-axis like that. And now I have my, now I have my, my 5 points, my asymptote, and then I just click this graph and then it draws the graph. Right, and then let's do one more. Let's get this over a little bit while I draw it. Okay, hopefully this won't knock us out again. I'm gonna plug in my board so I can write. So this time the function is, you guys let me know if it stops working. F of x equals 1/3 to the x. So again, we make a table of x and y values where y is 1/3 to the x. And your x value should always be -2, -1, 0, 1, and 2. So then I get, for my y values, 1/3 raised to the -2, and that's 3 squared, or 9. And then I get 1/3 raised to the -1, and that's 3. 1/3 raised to the 0 is 1. 1/3 raised to the 1 is 1. third. And by the way, guys, I always recommend write it out in the table like this so you don't accidentally square, like multiply this by 2 or something instead of squaring it. And then 1/3 squared is 1/9. And then, so unplug this just so I don't mess it up again. I just don't trust that now. All right, so now we're going to put those values in. So we want to use this to graph. So my first point, because we can graph everything with this, is -2 and 9, plot point, -1 and 3, click plot point, 0 and 1, plot that point, 1 and 1/3, plot that point, and then 2 and 1/9. Okay, and now I have all my points on there. Now I'm going to put on my asymptote, which is always at the x-axis, and then click the graph, and then it draws the graph. So that's how you do those.
So you only have to put 1 point and it'll draw the graph, because every time it keeps telling me that I need 5 points.
No, you have to put all 5 points on the graph.
Okay.
Yeah, you have to put all 5 of your points on the
No,
graph.
when I go to draw the line, the dotted line, the horizontal or the vertical, you only put 1 and then you click to draw the graph, then it did it.
Yeah.
I have all my points there, but then
Yep.
when I go to draw the graph, it tells me I need 5 points, and I have 5 points.
So you have to have 5 points and your asymptote.
Okay.
So make sure you have, so let me just, let me clear it and just make sure you guys see it. Start over. Working. Oh, it won't let me do it. So you have to put on all 5 of your points. And then you also have to add the asymptote before it'll let you click to graph it. If you're missing any of the points or you're missing the asymptote, it won't let you click the graph. I know you guys, I know it's a pain. So this is one of the, once you figure out how to do it, you'll be like, oh my gosh, this is not like, once you know how to, pick your points and everything, but sometimes Alex is such a pain. So were you able to get it to work? You need all 5 points and make sure that the asymptote is on the graph. So, and to put the asymptote on, and I don't think it'll let me do it without the points, but let's see. You want to make sure that you move it here, and then you have to click with your mouse so it stays. So if you don't click it, if you just grab the asymptote and you put it here, notice it's still moving around. So you have to put it on the x-axis, and then you have to click with your mouse so it stays there. And then you have to draw 5 points. And so they should always look the same like this. And this time my 5 points would be, oh, I think you don't even have to do it the way I was doing it. Let me just do it straight in Alex, because I think it might even let me put in the squared. So my first point is going to be -2. And then for -2, I'm going to do the reciprocal. So that's going to be 2/3 squared, which is 4/9. And then -1 and 2/3. And we always have 0, 1, and then 1 and 3/2. Oops, and 2, and make sure you clicked plot point, because that might be the other thing that's doing it. 2 and 9/4. If you don't click plot point and it's just sitting there, when you close it, then it'll only have 4 points. So make sure that you're clicking plot point each time and that all 5 points are on your graph and your asymptote. You can see the dotted line. So once I have all 5 points and my asymptote, then I can click this graph a function and it'll put it on there. But if you're missing a point or you're missing the asymptote, it will not graph it until you're done.